Welcome back. The objectives of this video is to define arithmetic sequences. We'll find the nth term of an arithmetic sequences, and we'll write the terms of arithmetic sequences. So, beginning with our definition of arithmetic sequences, a sequence whose consecutive terms have a common difference is called an arithmetic sequence. We've got a long definition here for essentially defining what D is. For example, the set of odd integers, the difference is 2, they have a common difference, that is an arithmetic sequence. Or even the set of even positive integers where our difference is 2. And this is really just a fancy way to find D. A sub 2 minus a sub 1 equals a sub 3 minus a sub 2. So we're saying if we subtract the first term from the second, it's the same as subtracting the second from the third, and we get our common difference of D. In fact, our sequence here for the odd integers, if I'm not mistaken, might be like 2n minus 1, where this is just simply 2n. In our first sample here, the sequence whose nth term is 4n plus 3 is arithmetic. The common difference between the consecutive terms is 4. We may be asked to find D here in something like that, like this. N was equal to 1. 4 times 1 plus 3, we get our first term is 7. When n is 2, our second term is 11. When n is 3, our third term is 15. And n is 4, our fourth term is 19. They all have a common difference of 4. In sample 2, we've got a sequence whose nth term is 1/4 to the n plus 3. Again, substituting 1 in for n, and 2 in for n, and 3 in for n, and 4 in for n, we get 4/4. N equals 2, we get 5/4. N equals 3, we get 6/4. N equals 4, we get 7/4. Our difference is 1/4. And a non-arithmetic sequence is just defined as a sequence in which the difference of consecutive terms is not the same. So the difference in this sequence, 1, 4, 9, and 16, we have a difference of 3, a difference of 5, then a difference of 7. So that is not an arithmetic sequence. Our second objective, finding the nth term of arithmetic sequences. Following this pattern, our first term, our second term is essentially the first term plus the difference. Our third term is the first term plus 2 times the difference. Our fourth term is the first term plus 3 times the difference, and so forth. So our nth term is equal to the first term plus n minus 1 times the difference, which again leaves us our formula here. So we can find the nth term of an arithmetic sequence by using a sub n equals a sub 1 plus n minus 1 times d, where d is the common difference. So looking at a sample, find the formula for the nth term of an arithmetic sequence whose common difference is 3 and whose first term is 2. So they're giving us our first term is 2, so our a sub 1 is 2 and d is 3. Substituting those values into our formula, our a sub n equals a sub 1 plus n minus 1 times d. We substitute 2 in for a sub 1, 3 in for d, and we can simplify. By distributing the 3, we get 2 plus 3n minus 3, and simplify, and we get our following form, a sub n does equal 3n minus 1. So then substituting in other values, for n equals 1 we get 2, and n equals 2 we get 5, and n equals 3 we get 8, and so forth. Our third objective, we want to write the terms of an arithmetic sequence. They tell us that the fourth term of the sequence is 20, and the 13th term is 65. So a sub 4 is 20 and a sub 13 is 65. They ask us to write the first 13 terms of this sequence. Some of you guys may see this in different ways, but to get from the fourth term to the 13th term, we travel through 9 different terms, and we cover a total of 65 minus 20, or 45 units. So we need our common difference 9 times to cover 45 total units. So some of you guys might see this as essentially 65 minus 20 over 13 minus 4, or 45 over 9, which is 5. So we get a D of 5. The textbook does this using our formula. So we get a sub 13 equals a sub 4 plus 9D, because we need to cover the difference 9 times. 65 equals 20 plus 9D. Subtract 20 from both sides, divide by 9, and we get a D equals 5. Or, as what we've done over here, 65 minus 20 divided by 13 minus 4. So then we can write our 5 terms. You may start at 4 and then subtract 5 till you get back to 1, and then fill in all the 5s until you get to the 13th term. There's a couple different ways you can do that, but those are our 13 terms in the sequence. And finally, another sample, a checkpoint. The 8th term of an arithmetic sequence is 25, and the 12th term is 41. So we've got this information here. A sub 8 equals 25, and a sub 12 equals 41. So substituting into our formula, 41 equals 25 plus, and then 4D, well, that's to go from 8 to 12. We got to go 4. That covers 4. We subtract 25. We get 16 equals 4D, and D equals 4. Or as some of you, or as I did earlier, we could do 41 minus 25 all over, and then since we had the 41, we do 12 minus 8. And we get 16 over 4, which is 4. And then we're asked to write the first 11 terms of the sequence. If we know a sub 8 is 25, we might start with that particular one and fill that one in. And a sub 12 is 41. We know our difference is 4, so I might subtract 4 from 25 and get 21. I'll subtract 4 again, and I'll fill out all my terms. So a sub 1 ends up being negative 3. A sub 2 is 1, 5, 9, so forth, all out to A12, which is 41. We just needed the first 11 terms of the sequence, so we would have stopped at 37 there. Wraps up the introduction to arithmetic sequences and finding the nth term of the sequence, and you'll get some more practice with this when I see you in class.